Alright, so let's continue on. So we're going to actually do number 19, and we're actually going to finish all of the problem on this one last video. Alright, so let's do number 19. So let's do, many couples believe that it's getting too expensive to host a average wedding in the United States, and according to a statistics study in the US, the average cost of the wedding in the US in 2014 was $25,200. Recently, in a sample wedding in the US, it was found that the average cost of a wedding was $24,224, with a standard deviation of 2,210. Which method should be used for finding a 95% margin of error for the sample mean for this in an example? So for this one, what you want to realize is how do we get the 24,224 and how do we get the 2,210? So if we kind of look at that, you want to look at where do they originate from. So the 2,210 and the 24,224 actually come from the 35. So it comes from a sample. So what we have to do, so since the standard deviation and the mean come from a sample, we have to actually use the t-distribution. Okay, anytime the standard deviation of the population is not known, and we only have the standard deviation of the sample, we want to use the t-distribution. So if you look at A and if you look at C, those are automatically incorrect because A is using the standard deviation of the population, and C, it has the z score on top of the radical n, which is just wrong. Alright, so let's move on to B and D. So if you look at B and D, both of them have the same standard error, so that's good. So let's just look at, so it says find the critical z value for the given level of confidence and multiply by the standard error using the formula of s divided by square root of n. For D, it's saying find the critical t value for the given level of confidence and multiply it by the standard error using the formula. So if you look at B, sorry about that. If we look at B, B is saying use a z value. On D, it's saying use a t value. So if we go back to what I said earlier, that we use a t-distribution when the standard deviation of the population is unknown, we know we're not going to use a z value. We know we have to use a t value, so that's why D is correct. Alright, so let's go to 20. So in 20, I'm actually going to give you the results. So for this one, all we kind of care about is your test statistic and your p-value. So whenever I say p is equal to blah, 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 this is actually telling you my p-value. So it's saying based on the p-value, what conclusion can be made? So this one, we kind of want to go back and look to see if there's a significant level or alpha. So if you look for the alpha, there actually is no alpha. So we automatically just assume alpha is 5% or 0.05. So anytime alpha is not given to you, we just assume that alpha is equal to 5% or 0.05. So for this one, we're going to say p-value and we're going to say alpha. So we want to see which one's bigger. So if we see alpha is 0.05, if we see p-value is 0.15, so 0.15 should be bigger than 0.05. So in this case, we'll say fail to reject the null hypothesis. So anytime we fail to reject the null hypothesis, that automatically conclude that there is not enough evidence to support the claim. So we kind of just want to look at A, B, C, and D and see which one kind of illustrate that. So if you look at A and if you look at D, it's saying reject the null hypothesis. So we automatically know these two are wrong. So now if we look at B, it says fail to reject the null hypothesis. So that's good. Then it said there is not sufficient evidence to support the claim that the average cost of eating away from home has decreased in 2009. So that one sounds really good. But let's check out number C. So it says fail to reject the null hypothesis. So where this one go wrong, it said there is sufficient evidence. So anytime we fail to reject, we can never say there's sufficient evidence. We always say there's not sufficient evidence. So that's why B will be the correct answer for that one. Alright, so let's do the final two problems. Alright, so 21. So 21 is asking the reading level of a random sample of men and a random sample of women is measured. Researchers want to know whether women typically read at a higher level than men. The sample. So in this, for number 21, all we want to figure out if the data set is independent or dependent. So independent just means that one subject is not going to influence the other subject. Dependent means that one subject will influence the other subject. So usually when we're talking about dependent data set, we're talking about like if I have a twin, one of the twin would go to one study, the other twin will go on the other study. Since we share the same blood and the same genetic, it will be like testing one person. So in that case, it will be a dependent data set. But if we get two random male from the street, those will be considered independent. So for this one, since you're comparing men versus women, this data set will be considered independent because pretty much there's no correlation between the man and the female or women. So that way it will be independence. Hypothetically, instead of the study doing with random women and men, if we would do it on couple, since we're doing it on couple and pretty much the couple are more correlated to each other, so if the husband read, the woman might read also, and vice versa. If the man doesn't read, the woman will also not read either. So in that case, it will be dependent. But for this case, since the man and female are separate and they're randomly selected, it should be considered independent. Alright, so for this one, if you look at it, is a before and after. Anytime it's before and after, those are usually dependent data set. Alright, so pretty much in the before and after, what they're asking us to do is look at the p-value, and based on the p-value, you want to figure out if we should reject or fail to reject the null hypothesis. But they also want us to write the null hypothesis and alternate hypothesis. So for this one, anytime we have dependent data set, it should always be HO mu of D is short for different, is equal to 0. So this state, no change. So mu D equal to 0, so that you're saying before and after, D lost no way. So then, the alternate hypothesis, you want to put mu of D and it's something 0. So for this one, you first want to kind of figure out how do they subtract it. Because depending on how they subtract it, it could be that a positive means that they lost weight, or a positive could mean that they lost, that they gained weight. So you want to see if they subtracted the before versus the after, or did they after minus the before. So let's see how they conducted the experiment. So it says she conducted a test on a sample of 4 randomly selected adults and measured the mood rating before and after being exposed to classical music. She is interested in testing whether the mean mood rating improved after an adult is exposed to classical music. Assume that all conditions are met. The resulting is as follows. So for this one, we just assume that what she did before minus after. So she got not that. She got mu of before and subtracted by mu of after. And so a negative will mean that they actually did improve, because if you look at the first one, you do 4 minus 5 and you get -1. So their mood actually improved, and a positive will mean that their mood actually went down. Alright, so that means we want to use A, and then you want to look at the p-value. So the p-value, well, alpha is equal to 0.05 because they don't state what the alpha they use. But the p-value, if you look at the p-value was 0.008. So 0.05 is greater than 0.08. So for this one, we should reject the null hypothesis. So since we reject the null hypothesis, we should state there is strong evidence to show that the exposure to classical music improved mean mood rating. So that way A will be the correct answer. B is not correct, C is not correct, because both of those are assuming that the dataset is independent, which the dataset is not independent. Alright, so let's do 23, 24, and 25, and we'll be done with this review. Alright, so for 23, if for 23, 24, 25 is asking, are the data set independent or is the data set dependent? So 23 said the productivity of a manufacturer plant worker is compared before and after the installation of air conditioning. So in this one, since it's a before and after are usually typical dependent data set. It's not, because pretty much they're gonna put they're gonna see how the worker are productive before and after they install the air conditioning. So we're gonna keep the same worker, but we're gonna see before and after. So that way 23 will be dependent. So 24 said the college GPA of identical twin are compared to see whether the mean are different. So same thing, this one will be dependent. The reason why it's dependent, because since they're twin, we assume they have the same genetic, the same DNA. So if one of them is doing well, we're assuming the other one should be doing the same. Alright, so 25, the weight of a king salmon from Lake Michigan and Lake Superior are measured. Researchers want to know whether Lake Michigan king salmon weighed less than those from Lake Superior. So this one, since we have two different locations and we have two different fish that they're getting, so for this one, it will be considered an independent data set, because pretty much both of the places are independent from each other, not like Lake Superior and Lake Michigan have anything to do with each other. So since these are two independent random places, the data set will be independent. Alright, so that's it for the final review, and if you have any question in regard to any of the problems, you could email me through Canvas.